Okay, you met binomial expansions in C2, and we're now going to do some more and extend the scope of the kind of binomial expansions that we can do. So hopefully you'll recognise this formula. It appears on the C2 page of the formula book. But in C2, the values for n that we had were only natural numbers. So we had n could be the power that you raise your bracket to, could only be 1, 2, 3, 4, not 1 really, that would be a bit boring, 2, 3, 4, 5, 6 and so on. But if you look at the definition, and this is directly from the C2 book, there's this bit that says n can be any real number. So we could have negative numbers for n, or indeed fractions. So we're going to look at some expansions where you've got n that is more than just the natural numbers. Okay, so before we start, this other part of the bit in the brackets here I'll come to later. But before we start, I just want you to write the formula in a slightly different way to how it appears in the formula books. I think it makes it easier to use it. It means the same thing, it's just a bit clearer, hopefully. Okay, so instead of 1 plus x to the n, I'm going to write 1 plus y to the n. Now, when you use this formula, what you usually do is you've got something like, let's say, 1 plus 3x to the minus 1, say, and you've got to replace what is in the formula by in this position. So the 3x has got to become the y in the formula. So if you've got an x in the thing that you're expanding, which you usually have, sometimes forget that you've got to replace the x in the formula by whatever you've got in this position. So hopefully this will make sense as we carry on. Okay, so we've got y 1 plus x to the n. So we're going to get the rest of the formula. So 1 plus ny plus n times n minus 1 y squared over, instead of writing 1 times 2, I'm going to write 2 factorial. Okay, now that's as far as the formula goes. It's then got some dots, and then it's got this general term for x to the r. But I'm going to write a couple more terms, which I think you'll agree is useful as we go on. So let's write the next term, which will be n minus 1, n minus 2, following the pattern. This time it's over 3 factorial, and it will be y cubed. Okay, next one. Hopefully I can squeeze that in. n minus 1, n minus 2, n minus 3 over 4 factorial, and that will be the term in x to the 4. Okay, now that's enough really, as you'll see when we go to do some examples. Now just to check here, with the general term, let's just look at this term here. We've got 3 factorial on the bottom, and we've got y cubed. And if you notice, in this general expression, we've got r there and r there, so they match, and that's right. And this term should be 1 less. So where we've got y cubed, the number we stop at here should be n minus 2, and so on. Okay, so let's look at some examples. Okay, so the first example we're going to do is 1 minus 3x to the minus 2. Sorry I haven't got room for the formula on this page, but you have it in front of you and I know it already, so we should be okay here. Okay, so let's start off. So we've got 1 plus n lots of y, so that's minus 2 times minus 3x. Next term is n times n minus 1, which I'm going to do in my head and put as minus 3, over 2 factorial, lots of minus 3x squared. Okay, next term will be n minus 1, n minus 2 over 3 factorial times minus 3x. For some reason doesn't want to write that, minus 3x squared. Okay. Now, obviously there are more terms, but I'm going to stop there and simplify them, and then explain to you why that is actually, well, it would be enough if I had written that as 3, which it should be rather than 2. Okay, right, so we have 1 plus 6x. Okay, next term, the 2 cancels with the 2 factorial. The minuses, I've got 2 minuses in here and 2 more minuses there, so it still becomes a minus. Okay, and I've got a 3 on the top there, and two threes in the brackets, so that's 27 lots of x squared. Okay, on this next term, 3 factorial will cancel with the 2 times 3. The minuses, I've got 1, 2, 3, and then 3 more minuses, so it's still a minus, they cancel in pairs. And I've got 4 times or 3 cubed, so that's 4 lots of 27s, that's 108. So we've got 108 x cubed. Now, if you think about the binomial expansions you've done in C2, so things like we might have had 1 plus 3x to the squared, then you know that when you get to the point where you've got n times n minus 1 times n minus 2, you get to 0, and so the sequence will terminate, and obviously with a quadratic you've only got 3 terms, so you'll have 3 terms and then that will be it. Now, because we've got n is a negative number, when we take away 1 from it and then 2 from it and 3 from it and so on, we're never going to get to 0. So in fact these sequences that we're forming are infinite. They go on forever, and for that reason they're not always valid. We're using the sequence as an approximation in this case for 1 minus 3x to the minus 2, and it only really makes sense if in fact we can use this for approximation if these terms in x, x squared and x cubed are getting smaller, and when they get so small that they become insignificant, so we can ignore ones after a certain validity. And in order to get these terms smaller, the thing that we're multiplying, we're squaring and cubing and so on, needs to be between 1 and minus 1. So in this case, the 3x needs to be between 1 and minus 1. And we can write that as the modulus of 3x is less than 1. So in this case, this sequence is valid as an approximation, as long as those numbers, the x and x squared and x cubed, are getting smaller. So another way of writing that would be to say the modulus of x is less than a third. So as long as we've got small values of x, this is a valid expansion or an approximation for 1 minus 3x to the minus 2. But it is only an approximation because obviously we could add more terms. Now you're often asked for the validity of the sequence, and to do that all you have to do is just to put whatever you've got in the position of y. The modulus of that has to be less than 1. Okay, now we're going to have a look at an expansion of a binomial where we've got a fractional n. We'll just do the same thing, so 1 minus x to the 2/3. So we've got 1 minus 2/3 of x plus, now I really recommend not writing down 2/3 minus 1, but doing that in your head. So 2/3 minus 1 is minus a third over 2 factorial. Pen's not working well today. Okay, and that's going to be minus x squared, and then 2/3 times minus a third times minus 4/3 over 3 factorial minus x cubed. Okay, we can stop there because we're asked only to go as far as the term in x cubed. Okay, so let's simplify that a little bit. So we've got 1 minus 2/3 of x. Okay, now you can use your calculator for your fractions, but okay, so let's just check our signs first of all. We've got minus in here, and then 2 more minuses, so that will give us a minus. So we've got 2/3 times 1/3 gives us 2/9, and then that's divided by 2, so it's 2/18 or 1/9 of x squared. Okay, and this last one, you'll have to take my word for it, is going to be minus 4/81 of x cubed. You can check that on your calculator. Okay, so we've expanded as far as the term x cubed. I always like to put some dots to show that isn't the end of it, but that's all we're asked for. And now we've got to say where it's valid. So the validity is where minus, the modulus of minus x, which is the thing in the position here, is less than 1, which is the same as the modulus of x being less than 1. Right, now we've got one that's a little bit different because here we've got a number that isn't 1 in the first position, and we haven't got a formula for that because we have to have 1 in that position, so we have to factorise it first. So we can take out a 4 and say that's 1 plus 4 lots of 1 plus x over 4, and that's all to the power of 3 over 2. So we can write that as 4 to the power of 3 over 2, multiply 1 plus x to the 4 to the power of 3 over 2. 4 to the power of 3 over 2 is a square root of 4, which is 2 cubed, which is 8. So, excuse me, so that's 8 lots of 1 plus x to the 4, x over 4 to the power of 3 over 2. And then we just use our binomial on the brackets, and remember to keep the 8 there as well. So we've got 8 lots of 1 plus 3 over 2 lots of x over 4 plus 3 over 2 times 3 over 2 minus 1, which is a half, over 2 factorial lots of x over 4 squared. Just make it a little bit smaller so that got room for the next term. So then we've got plus 3 over 2 times a half times minus a half over 3 factorial x over 4 cubed. Okay, so remembering our 8 outside, 1 plus 3/8 of x plus, okay, I won't bother to do the fractions out loud, you can do them yourselves on your calculators. So 3 over 128 x cubed, and this one's minus actually, minus 1 over 1024 x cubed. Okay, so we've just got to multiply through by 8, so we've got 8 plus 3x plus 3/16 of x cubed minus 1 over 128 x to the power, whoops, that is cubed, that last one should be squared. Okay, so that's what we were asked for, ascending powers of x up to x cubed, or the first 4 terms, so that is up to x cubed, and the only thing we've got left to do is the validity part. So here, when we used our expansion, it was x over 4 that we were using in that position, so the modulus of that has to be less than 1. So the modulus of x has to be less than 4. Okay, so this is our last example. So how are we going to use the binomial expansion for this? Well, we're going to rewrite the question as 1 plus x to the half, because the top of the fraction is square rooted, and then we're going to multiply it by 1 minus 3x to the minus a half. Okay, so we need to work out each of those expansions separately and then multiply them at the end. Okay, so we have 1 plus a half x plus a half times minus a half over 2 factorial x squared. We can stop there because we only need to go as far as x squared we can see from the question. So stopping there and then doing the second expression. So we've got 1 plus minus a half times minus 3x, and then plus minus a half minus 3 over 2 factorial minus 3x squared. Again, we can stop. Right, so simplifying, 1 plus a half x plus minus rather an eighth of x squared. That's the first bracket done. Okay, then the second bracket, we have 1 plus 3 over 2x plus 27 over 8x squared. Okay, now we need to multiply everything in the first bracket by everything in the second bracket, but we only need to go as far as x squared, so we don't need to do everything with everything. So let's start off by multiplying the 1 by everything in the second bracket. So we're going to have 1 plus 3 over 2x plus 27 over 8x squared. Okay, now we're going to multiply the half x by the terms in the first bracket, and I'm going to line them up underneath the relevant term in what I've already done. So half x times 1, I'm going to write here with the other x term, and then a half x times 3 over 2x, which is going to give me 3/4 of x squared. I'm going to write here. Don't need to multiply half x by the 27 over 8x squared, because that will give me an x cubed term, which I don't need. Similarly, when I come to the last term, minus an 8th x squared, I only need to multiply by the 1 here, because the other terms will be more than x squared. Okay, so because they're lined up, I can add them up. So I've got here 1 plus 3 over 2x plus x will give me 2x, and then I've got 27 eighths plus 6 eighths minus an eighth, which will give me 32 eighths, or 4x squared. So who would have thought something so complicated looking as the question would come to such a nice simple answer? Now we're also asked, it doesn't actually say, but I'm going to do it anyway, what the validity is. So if we think about the first expansion, so the 1 plus x to the half, that is valid where the modulus of x is less than 1. And the second one, 1 minus 3x to the minus a half, is valid. The modulus of minus 3x is less than 1, so the modulus of x is less than a third. So the validity for the whole expansion is that you have to take the tightest validity of the two that you've got. So the validity for the whole question is going to be, got room to write it, is going to be this one anyway. Okay, so because if you think about the first expression here is valid between minus 1 and 1, and the second expression is only valid between minus a third and a third. So the overlap in the two is this one.